Hi, my name is Ahmad Al-Assad, and in this video I'll go through the debugging with IntelliTrace using Visual Studio Ultimate 2012 hands-on lab. This video has been recorded for hands-on-visualstudio.com. In this lab you will learn about the IntelliTrace debugging feature in Visual Studio Ultimate 2012. Before the addition of IntelliTrace, debugging was done from a specific point in time going forward. If you wanted to find out more information for a previous call, you would set a breakpoint and then rerun the application. IntelliTrace enables you to seek to a large number of execution points that occurred in the past and drill into any of them, comparing variables, call stacks, etc., in order to help pinpoint causes of issues without having to reproduce the problem. The virtual machines for this lab has been pre-configured to archive source and symbols for the builds you are working with. This ensures that the files you get back from the IntelliTrace session can be correctly bashed to a particular build. In order to best take advantage of IntelliTrace for your software applications, you should review the following blog post, which goes into more detail and provides instructions for enabling this. To go through the labs, you need to download the Visual Studio 2012 virtual machine provided by Microsoft. This lab consists of two exercises: Introduction to IntelliTrace and Use IntelliTrace with call information. Exercise number 1. Introduction to IntelliTrace. In this exercise, you will see how IntelliTrace can help debug an XML data failure on an ASP.NET website. Note that IntelliTrace supports debugging Visual Basic and C# applications that use .NET versions 2.0, 3.0, 3.5, 4, or 4.5, ASP.NET, Windows Forms, WPF, Windows Workflow, and WCF. IntelliTrace doesn't support debugging C++, script, or non-managed languages. For more detailed information about IntelliTrace support, please refer to the Visual Studio 2012 documentation on the MSDN website. Now let's switch to the virtual machine. Log in as Julia, and you can find the password in the document or the screen. Now open Visual Studio 2012. If the solution doesn't exist under the Recent section, click on Connect to Team Foundation Server and select the Tailspin Toys collection, and then click Connect. Then click on Source Control Explorer, expand the team project, expand the development folder, and select the Iteration 2 branch. Then double-click on the Tailspin Toys solution. When downloading the solution, rebuild it by clicking on the Build menu and then click on the Rebuild solution. After the build is complete, open the Options window from the Tools menu. And then click on the IntelliTrace node. Ensure that the Enable IntelliTrace checkbox is checked and that it is set to IntelliTrace events only. This is the default settings because it has minimal performance implications. Note that IntelliTrace records events to an IntelliTrace file, which has a .itrace extension. These files can be saved and used later in order to perform debugging with IntelliTrace, enabling testers to attach this detailed debugging information directly to bug reports. Now expand the IntelliTrace node and select IntelliTrace Events node. Then select the File checkbox to have IntelliTrace record file events. Then click OK to close the window. Start a debugging session by pressing F5. This will load the default page for the fictional Tailspin Toys Company. Click the About Us page at the bottom of the page. This will generate an exception and will show a custom ASP.NET error page. Now we switch back to Visual Studio. Locate the IntelliTrace window and click on the Break All link. Locate and select the exception thrown event of type XML exception that occurs after the ASP.NET call to get the Home About page is loaded. This will show details about the exception that occurred, as well as provides links to the locals and call stack windows. This exception lets us know that there is a problem with an XML file on line 10, column 49, but it doesn't tell us which XML file this is referring to. Now select the file access event, which precedes the exception event. This event shows us the file that was accessed just before the exception occurred. Open the as.xml file by pressing on the provided link. Notice that there is a red squiggly line, which indicates that these are invalid characters in this context. Remove the invalid characters and save the file. Now restart the debugging session. Click the About Us link and notice that the page loads without any errors. Go back to Visual Studio and stop the debugging session, and then disable the IntelliTrace file events. And by doing so, we just completed exercise number 1. Exercise number 2, using IntelliTrace with call information. In this exercise, you will learn how to use IntelliTrace to collect additional call information in order to solve a more complicated user code error. Now let's switch to virtual machine. By default, only IntelliTrace events are collected when debugging, but we can also opt to collect data at every method enter, exit, and call site. To enable this, go to the Tools menu, Options, and then select the IntelliTrace node. Then select IntelliTrace events and call information. Then click on the OK button to close the dialog. Start a debugging session by pressing F5. Let's test out our shopping cart functionality by adding a couple of products to the cart. Click the Paper Airlines link to see the product catalog. Then click on the View Plain link for the Contoso Cloud Explorer. Then click on the Add to Cart button. Verify that the quantity equals 1. Now let's add another Contoso Cloud Explorer to the shopping cart by clicking on the Contoso Cloud Explorer link here, and then click on Add to Cart. Note that the quantity value is still set to 1, even though we added 2 products. Now we return back to Visual Studio. Select the IntelliTrace window if it's not already selected, and click on the Break All link. By default, we see the IntelliTrace events window showing the sequence of recorded events leading up to the debugger break. In the search box at the top of the IntelliTrace window, type post and press enter to filter the list. This will return 2 post events, one for each shopping cart item added. Select the first ASP.NET Post event and note that there is no source available for the event. This is expected because this is not our application code. Now select the second ASP.NET Post event. We will use this as a reference point to aid in navigating to the point in the debugging session where the add item logic begins. Now return to the unfiltered list of IntelliTrace events by clicking the X on the search box. Now select the first ADO.NET event that occurred after the selected event. This shows that each item added to our cart results in a customer lookup in the database. Select the calls view link to show a complete call hierarchy of the debugging session. The top frame of the calls view shows the stack for the currently selected call. Imagine that you are familiar with the code base, so we know that we need to navigate back in time to the process request notification call stack in order to locate the code of interest. Double-click on the call to system.web.hosting pipeline runtime.process request notification. In the IntelliTrace calls view, double-click on the call tailspin.web.app.controllers.cartcontroller.add-item. Each time you double-click on a call in the bottom half of the calls view, the call is popped to the bottom of the top frame, and the instruction pointer syncs in the code editor to the method entry point of the call, just like in live debugging. In the IntelliTrace calls view, double-click on the call tailspin.model.shoppingcart.add-item, and then double-click on the call to add item that shows tailspin.model.product. And then double-click on the call to add item that shows tailspin.model.product equal tailspin.model.product int quantity equal 1. Navigating through the calls view is a quick way to gain an overview of the call hierarchy and to make large jumps across the call hierarchy without stepping through line by line. Click on the locals window and expand the add method and expand the add function call. At any point in IntelliTrace debugging, you can look at the collected variables in the autos, locals, watch window, or by using the data tip in the editor. Now let's step forward 2 calls by pressing the F10 keyboard key twice. Note that we're stepping through the IntelliTrace recorded events and not the line-by-line code. In the locals window, expand the adjust quantity function call to see what quantity the cart is being set to after adding the second product. Since we are expecting the adjusted quantity to be 2, we have found the location of the bug. Stop the current debugging session and then change the add quantity call so that it adds the new quantity passed to the code item method. Now rerun the application to verify that the bug is fixed. Click on the paper airplanes, then view plane for the Contoso Cloud Explorer, then press the add to cart to add the item to the shopping cart, and click back on the Contoso Cloud Explorer link and click the add to cart button again. Notice that the quantity has been updated and the bug has been fixed. With this, we completed exercise number 2 and the lab. In this lab, we learned about IntelliTrace and how we can configure IntelliTrace events to capture certain events. We then analyzed the IntelliTrace events to find the line of code that caused an exception. We also learned how to configure IntelliTrace to collect call information events and use such information to find a bug in the code. At this point, I would like to thank you for watching this video.